cofunction formulas here, which are like equivalent trig ratios. And this is our question. It says, given that sine pi over 6 is equal to a half, we need to show that cos pi over 3 is equal to a half. So what this is saying is, imagine this is the only information we really know. Well, this is the only thing we know to be true. We somehow have to turn this into essentially this function, because we know that that function there, or that expression, I should say, is equal to a half. We can't say that this is. We don't know that it is. So we have to use these formulas here to somehow manipulate this to turn it into this idea here. Okay. So with that being said, in each of these functions here, or each of these formulas, we have pi over 2, which is really important. What that means is we need to use some version of pi over 2. And it may not be pi over 2, it could be an equivalent ratio. And there are tons of different equivalent ratios. We can write a whole bunch. Obviously, pi over 2 is one of them. We could also have 2 pi over 4. We can have, we multiply by 2, multiply by 3, 3 pi over 6, 4 pi over 8, and we can kind of continue with that. And what's important there is we need to, if we're going to use these, we need to find a denominator that's going to be common with the value we need to work with. So in the expression we're working with here, it has a denominator of 3. Okay, so because it has a denominator of 3, we can't directly, well, we can, but we really don't want to work in decimals. We want to work with whole numbers. We can't directly change this denominator into the value of 3. Okay, so what we'll do is we'll use a common multiple of the both of them. We're going to essentially find a common denominator between the two. So because this denominator is 3, and the original one we start with is the value of 2, I'm going to decide to change this entire question to work with the denominator of 6, because I know 6 is a common multiple of both 3 and 2. Okay, so with that being said, this is the expression I'm going to put into my cofunction formulas. Whichever of the 6 here I use, this is the expression I'm going to use. And I'm also going to change this one to have a denominator also of 6 in this case. So let's say that this is a tough idea. The whole point of this is what we're going to do right here, is we're going to split this into two values that either add, or in this case, was very specific, our formulas are written as subtraction, two values that subtract to equal this. So instead of just writing it as a split, I can literally make an equation out of it. I need pi over 2 to subtract from some value to equal pi over 3. Okay, that's the whole point of this. So with that being said, first of all, we're going to have to isolate for x, but this is where that idea of that common denominator is. Because when we work with fractions, in order to add or subtract them, we need denominators to be the same. I'm going to change this so that we have a common denominator when going through them. So my next step will be to change this to a denominator of 6, which means I need to multiply the bottom and the top by 3. And in this one here, I'll need to multiply the bottom and the top by 2. Does that make sense so far? Okay. So then we get 3 pi over 2. Subtract, and they've written theta, I wrote x. It's essentially the same idea. It's an unknown value. 2 pi over 6. Great. So now that I know that, I want to isolate for my x. Okay. So let's move our 3 pi over 2 to the other side. When we do that, we're going to be left with negative x is equal to 2 pi over 6. Subtract 3 pi over 2. Okay. Oh, sorry. That was a mistake. Did you notice I did that earlier? Mm-hmm. Okay. Just let me know when you see something like that. That should be a 6. And this should also be a 6. Okay, good. And it's good because when I did it, I obviously noticed all of a sudden my denominators weren't the same, so I couldn't use the math. When I subtract these values, this will actually end up being negative pi over 6 is equal to negative x. Is that okay? That's up there. And then what that means is positive x is equal to positive pi over 6. So let's go all the way up to the top. This is essentially my unknown value, okay, in one of the expressions. And I have to decide which expression I'm going to use. If we take a look, we worked with this idea here, 2 pi minus x, okay? And our original was cos. So let's rewrite this. I'll rewrite it in blue over on this side here. So cos pi over 3, okay, is equal to, according to this, we're going to split this part here. We're going to turn this into one of these sets of brackets. And we're going to use one that has cos. So let's look at all 6 of them. Which one uses the idea of cos? It's this first one here, okay? And it says cos pi over 2 minus theta is equal to sine theta. Okay, so we're going to use cos. And remember, cos, this expression is going to be equal to sine of whatever that unknown is. We know it's going to be pi over 2. What was our part here? And that's what all of this work was?
It's sine unknown if it tells you that, like, sine pi over 6.
Why is it sine unknown with pi over 6?
Yeah, why is it sine unknown and not sine pi over 6?
And you know what? You're right. We could do it to make this pi over 6, which means we'd have to be 100% confident that this is pi over 6. And there might have been more steps. For instance, when we split this, okay, we split this into 2 terms. And if you notice, if we go down to the bottom, our missing term was pi over 6. So that's what would fit in here, would be our pi over 6. We know that pi over 2 minus pi over 6 will give us our sine pi over, hold on a second, let me see what we got written here. What we proved was our missing value, that's what all of these steps in red here were. We proved that the missing value here was pi over 6. And since that was pi over 6, that means according to our cofunction formulas, this becomes sine pi over 6, which is exactly what we are trying to prove at the very beginning. So we know that this is, all of this together is equal to a half. Okay, so